Okay, so let me share my desktop. Can you see it?
No.
Let me know when it comes up. Sometimes it takes a little bit to load.
I can see it.
Okay, so on her, everyone will have the same question for 26, but you might not have the same numbers that she's got. If you struggled with this question, which I got a lot of feedback from people that this was one that was tricking people, if you struggled with this, then just take note of the strategy that we're going to use to solve it, and then go back and apply that to your question. So she's got here in a local election, 22,000. I'm just going to jot this down as I'm reading it. 22,400 people voted, which was an increase of 14% over the last year. And they want to know how many people voted last year. Okay, so I jotted it down on my whiteboard. I'm going to pull that up and we're going to go through it. We're going to round to the nearest whole number or two at the end because we're talking about people. So,
Hi, Miss Walker.
hi.
My name's Jay. I did have a question. So I had been trying to download my stuff. Um, and right now my laptop's not allowing me to download any assignments. It hasn't been allowing me to download it for a week, and I've been going back and forth with IT, so I don't really necessarily know what I should be doing about this.
Okay. I'll tell you what, Day. So you go by Day?
Yeah.
When we're all done with the call today,
Mhm.
stay on the line for a few minutes and I'll see if I can troubleshoot with you, at least to get you
Okay.
in.
Yeah, because I'm trying to do this assignment. I seen the assignment that was due for this week, but I wasn't able to do it because my computer's acting crazy.
I understand. For the first week or two, I try to be flexible with the due dates and all of that because of these problems. So um, just hang on the call when we're done,
Okay.
and we'll see if we can get you up and running.
Okay, thank you.
No problem. So Isaiah, I'm going over a homework question. So this is number 26. You'll all have the same question. You may have different numbers, but here is her information. So based on what I'm seeing here, since they're asking us for an amount from a previous year, normally we would have to work this backwards, but you can't work percentages backwards because if you don't have the base, you can't work it backwards. So what we're going to do, we're still going to use the percent equation to solve this, which in general form is that. That's what we talked about last week. But what I'm going to actually think about this as not necessarily a part in a whole thing, a total, but as a reference value versus a compared value. So last year versus this year, in other words. So when I plug this in, it's not going to be a part. It's going to be the voters from this year. So the 22,400 is going to replace this amount right here. Then I'm going to set that equal to the percent, but I'm going to account for the fact that there was an increase that happened by using this idea that we talked about last week, plus because it's an increase. So I'm going to account for the increase all in one step, which means I don't have to work anything backwards. I can just work it like normal and it'll work out that way. So my percentage is 14. So I'm going to plug this in as 114%. And then instead of this becoming the whole, it's now going to become the people from last year, the voters from last year, which we don't know. So I'm going to call that X. Now, to solve this, since I'm working with an equation, I need to change my percentage to decimal form. So I'm going to divide that by 100, which moves my decimal to the left 2 times. And now I'm working with 1.14 for the percentage. Now I'm in decimal form. And that's times x. And now I can solve this by just dividing. Instead of trying to multiply this by this and then work it backwards by subtracting, which wouldn't work because this is not the right base, I can just divide. Since I took the increase into account, I can just divide by this instead. So let me see what that gives me. Okay, 22,400 divided by 1.14 is giving me something like that. So if I rounded that off to the nearest whole number, it's about 19,649. Okay, so that should be the people who voted last year. Now let's stop and think about whether or not this makes sense for an answer. That's how many voters last year there were. So if 19,649 people voted last year, and then this year it increased 14%, and it's now 22,400 voters, that's a reasonable answer. It's pretty, I mean, it doesn't necessarily tell us if we've done it exactly correct, but at least it's a reasonable answer. If you want to check this now, the way that a lot of people work these problems, they multiply and then they add for the increase. That's the 2-step way of doing it. Then we should be able to use this percent equation as is without having to plug in the 100 plus or anything like that. This is just to check and make sure that this makes sense. So if we had 19,649 voters last year, and then we're going to increase it by 14%, we can multiply those two things together and then add it on. So let's see what that gives us. So what will our increase of our answer that we got of 19,649? Again, I'm going to just plug this right up into my calculator. 14% in decimal form times the answer we just got is giving me an increase of 2750 and about 0.86. So if I add that to that, let's see if I get my answer or something close to it. It just gave me 22,399.86. So to the nearest whole number, we're talking about people here, can't have a 0.86 of a person. So to the nearest whole number is 22,400 people. That's the only way then you can get back what you originally started with way back in the beginning here. So there's our check, and that's how we know that this 19,649 was correct. Okay, one more time to wrap up this whole thought process is when you're asked for something that you have to work backwards. So in this case, it was last year. You cannot multiply your percentage by the number you have and try to work it backwards. Percents don't work backwards because this was never the base. Okay, anything else?
No.
Okay. Okay, Christina, if you're speaking to him, just let him know I'm recording. If he's not able to get in, the recording will be up after we're all done. Unfortunately, I won't be able to troubleshoot with him during this call, so I can try to help him after the fact. Okay, just one more time, any other questions on homework, quiz, anything like that? It's not due today, just to remind you, it's not due today. All I was asking you to do for today was get the 3A questions started so that we could have a chance to go over it before we started the new section, which is going to be chapter 2.
Excuse me, I have a question.
Yep.
When is the quiz due?
Both of them are due next week.
Okay, for 3A and 2A.
Quiz are both due next week. So if you did not complete them, you still have some time.
Okay, thank you.
Okay, then it sounds like everybody is okay. We're going to start talking about the next part of Module 1, and we'll wrap that up today. So I am going to show you just real quick back in Blackboard here. In the modules, we are still working through Module 1 this week. We will finish it today, but this is where we've been from last week, and this is where we will continue this week. If you have not looked at this lecture yet, you need to. So this is just a quick review from what we talked about last week. This is what we did last week with section 3A. And now we're going to continue this module talking about 2A and 2B today. So you need to make sure you have looked over all of this now by the end of this week, going into next week. So what I'm going to do, because of the nature of the questions for this chapter, is rather than go through a PowerPoint, I am going to be working some things out on the whiteboard. So I think it'll work better that way. Chapter 2 is about converting and how you use proportional reasoning and unit analysis to work through problems. So it's still very much about proportions and how you use units to work through a problem, but now it's going to be a different application. Now we're going to be talking about conversions. Anybody who's in the healthcare fields, this is going to directly impact you, because you're going to have to do problems like this. So having said that, what I'm going to do is I have a few examples, and I'm going to post these notes to Blackboard also, so you can kind of take a look at this after the fact if you want to follow along with me later. I have a couple of examples that I want to go through, starting with something pretty basic. And I want to set this up just to show you how the method, I'm going to give you two methods actually, how to show you how the methods work with a very basic type of a question, and then we'll kind of ramp up the difficulty from there. So for example, for the first example, they're asking you to convert a distance of 9 feet to inches. All right, so like I said, I'm going to show you 2 different ways to do this. There's more than 2. I'm just going to stick with 2. One of them is a proportion, and we're talking about proportional reasoning right now, so that makes sense. The other one's called unit analysis, which it's just a different method. Depending on the course that you're taking, you might have some nursing instructors that do it one way or the other, so I want to make sure we go through both. All right, so for method 1, which as I said is going to be to use proportions. What I'm going to do, you can set proportions up in several different ways and they all work as long as the correct things are across from each other, it'll work. But what I'm going to do is I'm going to take my starting unit, which is the 9 feet, and create my first ratio using the thing that they're asking for, the inches. So since I don't know what that is, I'm going to make that X inches. And then since it's a proportion and the two ratios are equal, then if this is in my numerator on my left-hand side, then the feet have to match that over here on the right-hand side. These have to be equal. And then same thing for the denominators. If I made inches the denominator in the first ratio, I have to keep inches down here in the second denominator on the second ratio. And then what gets filled in on the second then is the conversion for feet to inches or inches to feet. So there are 12 inches in 1 foot, and now everything is set up. So again, this is not the only way to start this, but this is how I'm going to go through each one just to stay consistent. So I take my starting units, and I create my first ratio out of that. And then over here, I got those numbers and that information by using the conversion for inches to feet. Now, we talked about this last week. If you remember, to solve a proportion, you just cross multiply. So it's going to be x times 1 equal to 9 times 12. X times 1 is just x, 1x. And then I got my 9 times 12. So since x was inches, then this is now 108 inches. Okay, now you're probably sitting there thinking, can I just multiply? Excuse me. I'm going to take a drink. If you're sitting there wondering if you should just multiply by 12, yeah, you can. This setup consistently sets everything up no matter how difficult your conversion is. So inches and feet are something that's pretty basic to work with. If you already knew that you could just multiply by 12, that's great. But this is the setup for everything, and it'll work for everything no matter how complicated they get. So that's the idea. So I want to just introduce with an easier type of conversion so you understand where this is all coming from. So having said that, let's talk about method 2. We already know it's going to be 108. So let me show you how the other method sets up. You can use either one. It's just a personal preference. But like I said, a lot of other instructors that I have come in contact with do it this way, so I want to show it to you so you're familiar if you get into those nursing classes. So we take the starting unit, which is the 9 feet, and we're going to create a fraction out of this. So since 9 is a whole number, I'm just going to put it over 1. No label required. It's just 9 feet. I put it over 1 to make a fraction. Then for this method, you don't set them equal. You're going to multiply. So what comes next is the conversion, but we're going to set it up so that the units that we don't want anymore will cancel, and so that the units that we do want will remain. In other words, I have to keep the feet diagonal now. Instead of being across and equal, feet now have to be diagonal. And then the inches that I want will go up here in this new numerator. So the conversion numbers are the same. They're still 12 inches in a foot. But now things are set up a little bit differently. And again, because we're multiplying fractions, you can cancel when things are diagonal, and that's the whole idea. So the feet, we're going to cancel. And then this is just telling you to go straight across at this point. So 9 times 12 is 108. Over 1 times 1 is 1. And when you simplify that, it's just 108. Inches never cancel with anything, so it is now the new unit. All right, so I'm going to pause, stop. Do you have questions at all? You can't see the problem. Can everybody else see the problem?
I can see the problem.
Okay. Brianna, it might be some sort of setting with your with Skype then, if you can't see it. But I'm recording, and I'm going to post it to YouTube, so you'll be able to see. You'll be able to see it later if you can't see it right now. Okay. Any questions for me?
I have a question, but it's not on the problem that we just did.
Okay, go ahead.
When I was doing the homework, there was a conversion that I didn't know. I don't know all conversions by heart. Do you want us to know all of them by heart?
No. That's a good question. Okay, so I'm glad that got brought up. No, you do not need to memorize conversions for this class. What I will do is I will post a reference sheet that will include many of them, but again, it still may not include everything that comes up in your homework. So I have the reference sheet as a suggestion 1. Suggestion 2 is to go into the textbook and see if they have any conversions posted. For example, I just pulled this one. This is right from your textbook, if you can see that right there. This is table 2-1 from your textbook. It's got a whole bunch of things on it. There's many tables throughout that book. And in worst for worst, you can Google it. Use your resources. We're blended and online, so whatever you need to do, if it's a very strange conversion, you might have to just Google. You don't have an actual textbook. We have an ebook. So I'll show you guys again when we're all done talking about some of these examples where you might be able to find some of these conversions that way. Okay, so no problem. Having said that, any conversions that I'm showing you, I'm going to just give them to you or show you where I'm finding them at least. And then from there, oftentimes my math lab will give you a little table that you can click on as well. So good question. Don't worry about memorizing anything. I will tell you this, if you're in nursing classes, you will have to memorize quite a bit in the future. So the more you start to learn now, the better you'll be. All right, let's try one that's a little bit more complicated. I actually have a picture here that goes along with it. So it's saying how many cubic feet of soil are needed to fill a planter that's 6 inches long by 4 inches wide and 10 inches tall. So here is my problem here. They want cubic feet, 6 inches long, 4 inches wide, and 10 inches tall. So imagine that you've got this thing, this little planter box here, and they're asking how many of these little cubes would fit in there. So let me jot down the information first. We have 6 inches long, 4 inches wide, and 10 inches tall, so height. question wants to know how many cubic feet. Okay, so that's an issue. There's a problem. We're working with inches throughout this whole problem, and they want cubic feet. So we're going to have to do some conversions, but we need to get things written in cubic form before we can do that. So if they want cubic, anytime you see cubic, that's three-dimensional measurements. They're asking for volume. So in order to get these measurements in cubic form, we have to find the volume of this planner first. Since it's rectangular, we can just multiply the length times the width times the height, and that'll get us in cubic form. So 6 inches times 4 inches times 10 inches. So 6 times 4 is 24. 24 times 10 is 240. An inch times inch times inch is inch cubed, or cubic inches. That's how we get it in cubic form, by multiplying each of these units together. Now, if it was how many cubic inches is that, we'd be done. And since they want cubic feet, we now have to convert this. All right, so now we've got to figure out what this conversion is. So I'll just tell you, you can look this up. This paper that I pulled out from your textbook has cubic measurements right here somewhere. Let's see. That's a little bit blurry. It says 1 cubic foot equals 1,728 inches. So I'm going to just write it down. But here's another thing I want to show you briefly. If we didn't know that, we had no way of finding that, you can get it yourself. If you know that 1 foot is 12 inches, and you want this all cubed, then just cube everything. So what I mean is 1 times 1 times 1 is 1. Feet times feet times feet is feet cubed, cubic feet. And over here, 12 times 12 times 12 is 1728. An inch times inch times inch is inches cubed, cubic inches. That's where those are coming from. If you didn't know, or if you weren't able to look it up, you could just figure it out yourself. So now I've got to use all of that and convert this. So for the sake of time, I am going to do it one way, and then for the next one, I'll do it the other way, and we'll try to practice it both ways, flip-flopping question by question. So for this one, I'm going to try it with the proportion. I'm going to use method 1. Method 1 takes the unit that you're starting with, it puts it over the unit that you want, and then it's equal, because we're going to do proportion. So equal means they need to be the same. Inches cubed up here in the top, feet cubed down here in the bottom. And I'm going to fill in my numbers then using the conversion that we talked about just now. So the 1728 goes with the inch cubed, and the 1 goes with the foot cubed, cubic feet. So now I'm all set up, and now I'm going to cross multiply and solve this. So 1728 times x, and 240 times 1, this is 240. Now I divide to get x by itself. so that cancels. And then I'm going to plug that in my calculator. Decimal form, I'm getting a repeating answer. Oops. Oh, so let's see here. In fraction form, if I reduce the 240 over the 1728 instead, I would get this as an answer. So just depending on what you need, if you need it to be exact, the fraction form is exact. If it's okay to round it off, then you could work with decimal form. Something like this. Either one. Just pay attention to what my math lab wants. All right, questions about that? Okay, let's see. All right, so we're gonna continue since I'm not getting any questions, it seems like. And I'm gonna introduce the metric system to you. The metric system can be converted with proportions or unit analysis, like I've already showed you. But you can also use the metric prefix line to convert, which is just moving decimals back and forth, multiplying or dividing by 10. So I'm going to show you that way as well. And that will work for anything that's metric measurements, metric to metric. Okay, so let's talk about the metric system briefly first, and then we'll do an example. So the metric system is all based on powers of 10. They have base units that they work off of, and then they either multiply by 10 or they divide by 10 to convert their metric measurements. This only works, by the way, what I'm going to show you if you're going from a metric measurement to another metric measurement, is to move your decimal back and forth. So let's talk about this metric prefix line. The basic metric prefix line looks something like this. These are just my abbreviations for it. The K represents the prefix kilo. Prefix means it's coming before a root word. H represents hecto. DA is deca. This blank line is the base unit. So this base unit takes the form of whatever it is you're measuring. If you're measuring length, then it is the meter. Which is abbreviated with an M. If you're measuring weight or mass, then it's the gram. If you're measuring volume or liquid, it's the liter, which they abbreviate with usually a capital L, or you might see a little scripted L. They do that to try to make sure that it doesn't look like a 1. But it could be other base units here. It could be like the watt, for example, if you're measuring power. So these are the 3 main ones. Then D is the prefix deci, C is centi, and M is milli. Okay, and again, they're all prefixes. So let's say we were measuring length. This would be the kilometer, the hectometer, the decameter. This spot is just the meter. Then it would be decimeter, centimeter, millimeter, and so on. If it was the gram that we were working with and we were trying to convert weight, it would be kilogram, hectogram, decagram, gram, decigram, centigram, milligram. That's how this line works. The little saying that I know to remember the order of these is King Henry died by drinking chocolate milk. Just a little saying to help you remember, kind of like, please excuse my dear Aunt Sally, full order of operations. If you can remember this, then you know the order of your prefix line. But you don't have to memorize a whole bunch of conversions then. You just need to move your decimal back and forth. Now, another thing before we talk about the examples that I want to bring up is, since visually over here on the left, these are the larger units, and over here visually these are the smaller units. If you're moving to the right on this prefix line, when you convert, any move to the right is essentially like multiplying by 10. Each one. If you move 3 times, if you have to convert from here all the way to here, going 3 times, then you multiply by 1,000. Any conversion going to the left is the opposite. It's like dividing by 10. So if you have to move left twice, you would be dividing by 100. So that's something you can keep in mind when you're doing these. Otherwise, just be careful, move your decimal very carefully. So I'm going to give, we're going to do one example real quick just to show you how to use all of this. Let's say we were trying to convert 0.2 of a gram, 0.2, to milligrams. And again, we can set this up the same way we did the other ones. We can do a proportion, we could do the unit analysis and cancel units, or since we're talking about a metric measurement converted to another metric measurement, we can just move our decimal back and forth. So we put ourselves on this prefix line where the starting unit is. So we're talking about the base unit here since we're working with the gram. We're starting here. And we're trying to go to milligram. We need to convert it to milligrams. So we're going to move to the right 3 times. What that tells you is move your decimal to the right 3 times. So if we're starting at 0.2, all we need to do is 1, 2, 3, and move it over 3 times. Put some zeros in these empty spots, and then we're done. So 200 milligrams. So that many grams is equivalent to that many milligrams. If you don't like moving decimals, if you're just get confused about how to do that part, then again, let's go back to what I said a second ago. Each move is multiplying by 10. So we moved it 3 times. 10 times 10 times 10 is 1,000. So you can just take your 0.2, multiply it by 1,000. And that'll also give you 200. So we're talking about 200 milligrams. That's how the metric prefix line works. Do we have any questions about that? Yes, I am recording, Ashley. Okay, let's see here. I'm going to switch gears. Let's talk about some questions that you might see from 2B. So that's pretty much wrapping up 2A. That's just its basic conversions back and forth. So anything that's coded on my math lab in 2A, that's pretty much all you're going to need to do. You either set up proportions or the unit analysis, or you can just move your decimal back and forth if you like, if you're looking at 2 metric measurements. Okay, now 2B is more complex application-based problems. So I'm going to start off with something like this. You are planning to make pesto and you need to buy basil. I pulled this right off from the book, by the way. At the grocery store, you can buy small containers of basil priced at $2.99 for each 2/3 of an ounce container. At the farmer's market, you can buy basil in bunches of $12 per pound. So which is the better deal? So I'm going to write all this down. We're talking about the grocery store, which they're selling it for $2.99 for a 2/3 of an ounce container. At the farmer's market, they're selling the same basil for $12 a pound. When it's $12/pound, it's $12 for one. All right, we need to figure out what's the better deal. So whenever they ask a question like that, they're asking for the unit cost. Or the unit price. A unit cost is the amount something costs per unit, per one unit. So if I wanted a unit price for this, it would be the dollars for 1 ounce. The unit price for this is actually already a unit price because it's the price per 1 pound. The issue I am starting to see right off the bat is that I have 2 different sizes that I'm trying to compare, and this one is not in unit price form. So I need to figure that out as well. So starting, let's change this grocery price. Instead of it being $2.99 for 2/3 of an ounce, I want to know how much is it going to cost for 1 ounce, because then it will be in a unit price. At least I'll have something then I can convert or try to convert. So I'm going to take my 2/3 of an ounce first. And I'm going to divide that by the price. So the $2.99 divided by the 2/3 is going to give me the price for 1 instead. So I'm just plugging this in right into my calculator. $2.99 divided by 2/3. To plug this in, you can just put it right in fraction form if you have a scientific calculator. And that's what I did. And I'm getting 4.485. So it's about $4.49 when I round off to the nearest penny, to the nearest cent. Okay, so now I'm working with that for 1 ounce and the $12 for 1 pound. So now I want to get these to be the same unit. I can either change them both to ounces or both to pounds. And in this case, it's probably easier to change the ounces to pounds because it'll give me a whole number. Versus this, I'll have to work with a decimal or a fraction if I go the other way. So 1 ounce is how many pounds? It's already, since I got it in unit form, it's just a conversion. I just have to look that up if I don't know it. There are 16 ounces. In one, oops, I said that is all backwards. 16 ounces in 1 pound. So this is the one I'm going to try to change. I'm sorry, I said that backwards. Because it's easier to just go to the conversion. I have 1 pound and 16 ounces. And I don't have to do anything other than look it up. But now I created another problem for myself because now I'm not in unit price form anymore. Unit price is the money for 1. Now I have it in the terms of the money for 16. So I'm going to divide this again. 12 divided by 16. $0.75. So it's 75 cents per 1 ounce now. Per 1. Now I can compare all of this. There's a lot going on right now. So I just figured out that it is going to cost me $4.49 if I buy 1 ounce of basil at the grocery store versus 75 cents per ounce at the farmer's market. I've got dollars matching dollars, ounces matching ounces, so now I can compare these apples to apples, and clearly this is the much better deal. Okay, so let me just review everything that I just did in order to arrive at all of this. I started by looking at what the question was asking. If they want the better deal, I need to get unit costs for my items. To get a unit cost, divide the money by the size every single time. So that's what I started with. This one didn't have a unit cost because this was not a 1. So I divided $2.99 by 2/3. That gave me a unit cost. I looked at the second one and it was already a unit cost because I had money per 1 that I started with. So I didn't have to worry about that. Then I looked at them and I tried to compare and saw that my sizes don't match. So then I converted them to the same thing. I chose ounces that I was going to go with just because that's the one I picked. You could have changed them both to pounds and it would have been perfectly fine that way. You would have been able to compare no matter what, as long as it's apples to apples, ounces and ounces. You'll be able to see which one is the cheaper one regardless. Any questions about that? Okay. Let's see. I'm going to pick one more and try to wrap this up. Let's see. You might have something like this come up in your homework, so we'll go with this one here. Okay, again, this is with 2B, it's a little bit more application based, so I'm going to pull something like this one here for anybody in the healthcare fields. We can talk about how this is used for you actually out in the field. So a child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dosage based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. And then they have 2 parts to this question. How much amoxicillin should the child be prescribed every 12 hours? So basically, how much should the child get per dose? And then here, if the medicine is to be taken in a liquid suspension with a concentration of 25 milligrams per 2 milliliters, how much should the child take every 12 hours? We'll talk about that here separately. So first, I'm just going to jot down all of this information that they're giving me in the problem, and we'll talk about the first part of the question. So we have 15 kilograms, which is the child's weight. And then we have the dosage, which is based on 30 milligrams per kilogram of body weight, and that's per day. And it's divided into doses for every 12 hours. All right, the first part of the question says, how much amoxicillin should be prescribed every 12 hours? Okay, so let's talk about now how we're going to go about this. Let's break this down. So you've got a child who weighs 15 kilograms, and this dosage is 30 milligrams per kilogram, meaning per 1 kilogram. So the very first thing we're going to have to do is figure out how much we're going to give this child per day, because that's what this dosage is measured in. So they get 30 milligrams if they weigh 1 kilogram, and this child weighs 15. So all we really need to do is multiply this. But I'm going to use that unit analysis setup to show you how this whole process would work. So the child weighs 15 kilograms. There's no other unit attached to that, so I'm just going to put it over 1 and make it a fraction. 15 is a whole number, so I put it over 1. Then they told me that they're going to get 30 milligrams per kilogram. If I multiply by 30 milligrams per kilogram, then this setup will show you that the kilograms will cancel, and that all you need to do is multiply this out to get the number of milligrams, how much amoxicillin, how many milligrams, but it'll tell us per day, because that's what this is measured in. So 15 times 30 is 450 milligrams is what's left. 1 times 1 is just 1. So this child is going to get 450 milligrams per 1 day. I'm going to add this back in now. So the day is still there, and now the milligrams are all that's left up here. Now, the question, they don't want to know how much the child gets per day. They want to know how much this child gets every 12 hours, which means every dose. The dose is given twice a day if it's given every 12 hours. So I'm going to take that now, and I'm going to use that to show how we're going to get this answer. Now, obviously, again, just like the original question, you can just divide this by 2 if you can think it through that way. But if you need to use this setup to show you how things work out mathematically, then it would look like this. The day would have to be across, diagonally across, so that that would cancel out. We'd no longer have days anymore. And then we would take this by 2 doses. 2 times a day, or 2 doses per day. Then my days cancel, and it's going to tell me that 450 times 1 is 450. Then I have to divide by 1 times 2 doses, which is 2. That's how I know I have to divide by 2. Again, that's how the math will all work itself out. So all I need to do then is simplify it out. So 450 divided by the 2 is 225 milligrams per dose. Any questions about that before I do part B? Okay. All right, so part B says here, if the medicine is to be taken in a liquid suspension with concentration 25 milligrams per 2 mLs. So basically, here's what's happening. You've got a young child who can't swallow pills. They have to take it in liquid form. The concentration is 25 milligrams for each 2 milliliters. So how much should the child take? How much should this child drink then? They're going to mix up the medicine into this solution so that the child can drink it. And they want to know how much that child is going to have to drink. They're asking for milliliters then. Milliliters is the liquid here. So the question essentially has changed to that. How many mLs should we be giving this child per dose? All right, so let's talk about how we can do that. We know we have to give this child this much per dose. So we're going to use this information that we just found and use this to cancel with the concentration that we were given, which was the 25 milligrams per 2 mLs. Now I'm going to use this. I'm going to do the unit analysis setup again since I started with that. And this is how I would multiply this out then. Milligrams will go diagonal so that they cancel. We don't want this answer in milligrams anymore. We want it in milliliters. I need those to be diagonal so that they'll cancel. And I need the mLs to be up top so that one is retained in my answer. So this concentration that they gave us in this order is just going to have to get flipped. We'll put the 2 up here instead. The 25 is going to go down here then with the milligrams. Then I'll multiply this out. So the 225 times the 2 is 450. Milligrams just canceled. And the 1 times the 25 is 25. So I am in milliliters per dose now, and I just have to divide that through. 450 divided by 25 is 18. So I've got 18 milliliters per dose. They wanted milliliters every 12 hours, which is milliliters per dose. So I answered the right question, and this is done. Okay. All right. Questions at all about any of that stuff? We're almost out of time, so I want to wrap this up. Okay. All right, now let me just tell you guys the questions that we did. Those are the general methods for solving all of the rest of the problems in your homework. So I want to stop here because we did a few examples. If you need to look this back over, I will post this to Blackboard. I will post the video. So what I want to do before we run out of time is go back to Blackboard and show you now everything that you need to do for next week. So including what should have been started last week. So I'm going to go right from the beginning here. I'm in Blackboard. Here is what you're going to do. Click one of your modules.
Hi, I can't see the screen. It's saying it's been loading for a minute and it says it's black.
Okay, that's Destiny. I'm going to try to reshare and see if that helps.
I can see it now.
Okay, good. All right, so let me continue then. So now that we finished up the lectures, or the Skype call lecture, I should say, here is how you should proceed for the rest of the week leading up to next Friday. You need to go into Blackboard, click on modules, and if you have not done this already yet, start with the lecture that is available through Blackboard. You want to click on Begin. And now the whole module is completed, so you need to look through this whole thing. If you've already started, you're halfway through it. If not, you want to go through and look at this whole entire lecture. Click on the boxes when they come up, and make sure you understand how to do some of these examples. Between what I just showed you and what is here, hopefully that will be all that you need. Okay, once you are finished with that lecture, you can close this out. Then you go to your assignments and see what it is you have to do. Just like for last week, you are just continuing to work on this homework and finish up your quiz if you haven't done that yet. So now I got to go to my math lab to access this. Your book is also located in this tab. If you go down to the bottom and click on the multimedia library, this is how you can get to your ebook. So I'll just show you this real quick. We're working in chapters 2 and 3, so you might want to just keep it as all chapters. Click on the multimedia textbook box and then click Find Now. Okay, this will pull up the entire book, chapter by chapter. We did 2A and 2B today. So if you're looking for a conversion sheet, and as I said, I'll post one of my own, but the textbook should also have some things available as well. If there's a obscure conversion that they're asking you for, let's see if it comes up. I'm loading a little bit slow, but I think it's going to work. Okay, here's your textbook. So people who have been asking me about the textbook, you don't have a physical copy of a textbook. You've got this online ebook. So here's where 2A starts, because that's where I clicked on. And if you go through this chapter, you navigate the pages with these arrows here. You should see some conversion charts within this chapter. I'm not sure what page they're on, but this is something that you were supposed to be previewing anyway. These are where I got some of these questions that we did in class 2. I took them right from your book. Let's see. Here, it's got to be close. Here where they're talking about unit conversions. But anyway, if you go page by page, you should start to see some information come up with where these conversions are coming from. Again, if you don't find what you're looking for, just do a little Google search for the conversion that you need, whatever they're asking for. So if they're asking for cubic yards and cubic feet, and you didn't know that this was the conversion for it, you can find it in the book, or do a Google search, or check their reference page that I'm going to post. There they are. Finally, we got to them. So here are some of the ones that I was using today when we were doing the problems. And there's several tables that look like this. You just have to go dig through the chapter if you're looking for something specific. Okay. Any questions, by the way, about this ebook? I never showed this to you. I just told you where the directions were. Is everybody okay with that? Okay, so let me close it then. Go back here. So that's the multimedia library, is the textbook. So I want to go into the homework and just remind you from what we talked about last week. You should hopefully have started Module 1. And now you should be able to complete all of Module 1, including the 2A problems that we talked about before. They're going to ask you a few questions about unit prices in 2A, basic conversion types of questions from 2A. And then 2B, let's see here. 2B will be a little bit more challenging type of applications, but they're all done pretty much the same as what we were talking about before. You need to do unit ratios and compare prices, better costs, and things like that. Okay, once you finish that, you can save it. That'll tell you your score. If you get anything wrong, like I got here, I can go back in and try it again. You have 3 attempts at each problem before it will mark you wrong. And then, let me get it, I want to get it wrong again. Once I'm done with the final check, if it's wrong, I hit similar question and it'll reset my problem and I can try it again until I do get it right. Once I do get it right, it'll change this red X to a green check mark. Okay, so everybody can get 100 if they want to just continue to try that. Once you're done with all of these homework questions, go back and now take your quiz. So you will go back to Blackboard and click on Quizzes and Tests and take your Module 1 quiz. You have a limited attempts at this as well. And this one is just 8 questions long. If you submit this and don't like your score, you can take the quiz again. You can just continue to take it until the time closes when the due date comes. That's pretty much it. If you've got all of that taken care of, then you're done for this week. Any questions for me before we end? We've got a couple more minutes left. Next week, quiz and homework both due next week. Check your tracking calendar for all the due dates.
Okay, so for the so you want me to try? Well, I can't download anything right now, but as far as for the tracking calendar, I mean I can't download anything, but for those assignments, what day is it for last week? What day is that due? Is that due today or tomorrow?
Homework and quiz was not due at all today. I wanted you guys to start it. Everything is due next week.
Okay, so there was no homework for last week.
Just to start it, yeah, but nothing due.
Okay.
Okay, anybody else have anything for me? I'm going to stop sharing and make sure I grab a screenshot of the attendance real quick. Okay, if you have no questions, then you can sign off. If you do have some questions or you need me to help you, like Deja, if you want to stay on, I'll try to troubleshoot with you. Everybody else, have a great weekend and good luck with everything.
Thank you. Have a good weekend.
You too.
Thank you, you too.
Okay, so as far as I've been trying to troubleshoot my computer for literally a week now on all different platforms, and I just cannot figure out why every time I download anything, it says file failed virus
Okay.
or something like that. And I've tried several different troubleshooting techniques, but none of them seem to be working.
Okay. Are you on Skype through your computer right now, Day, or are you on a phone?
I'm on my phone right now.
Okay. Let's see here. Great. Are you able to get into Blackboard?
Yes.
All right. Can you go into Blackboard? We're gonna go step by step here and see
Okay.
what each page is saying.
Well, all the pages are fine as far as like
So when you click
you
on the
know,
links, right?
yeah, I can
Okay.
click all the links and everything. It's just when it's time to actually download it to my computer so that I can open it up and like whether it be Word document, Excel, or anything like that, I can't do any of those things.
Okay. So
is this?
What kind of laptop is it?
It's a Dell laptop. It's one of the laptops that the school was giving out.
Okay. So that shouldn't be a problem. All right, go into Blackboard, click on Welcome Start here. Let me know when you're there.
Okay, give me 1 second.
No problem.
All right. Okay.
Right. Then click on where it says the course syllabus, and I want to know. Tell me what the name of read it. Tell me what it says.
Okay, so when I try to click it open, it downloads, it goes to my files, it tries to save, and then as it tries to save and it's actually downloading and the percentage is loading, it stops at the last percent and goes to failed virus.
Okay. You said you've been talking to IT about this?
Yeah, I'm waiting on them to respond to me right now about it because they're supposed to be working with me to try to fix this.
Okay. When did you first contact them?
2 days ago.
Okay. Have you
Yeah.
heard from them? So you have heard from them. Right?
Yeah, and they gave me instructions on what to do, and that didn't work. So I sent back an email yesterday about it not working, and I'm still waiting for the email back to see if like it's possible for them to like come like log into my computer from while I'm at home.
Mm-hmm.
And they told me I had went up to the school actually. What day was that, on Wednesday? And they told me that IT probably won't be in until Monday.
Okay.
So I would have to go if nothing works this weekend. I would have to go on Monday back up to the school so that I can get the physical help.
Okay. It sounds like there is some sort of virus protection that they loaded into those computers, which is not uncommon. If it's coming right from the school, that's probably what it is. And for whatever reason, it's blocking all of your downloads. So the only, I'm not IT, so they would be the best person. I was just hoping that it was something else.
Yeah, I don't know. It's definitely the computer though. Like, it's nothing else because like I can get into Blackboard just fine.
Okay.
I can see everything just fine. It's only when I try to download these things.
Okay. So next question then. Have you tried looking at some of this stuff from the phone?
I have not tried looking at it over the phone.
Might be able to. What kind of phone? Do you have an Android?
I have an iPhone.
An iPhone?
Mm-hmm.
Okay. Gosh, that might cause another problem. Here's a couple of suggestions, just at least to get through the weekend, so you don't continue to get further behind. You might want to try going through. Just pull up whatever web browser you use on your phone, and go to Blackboard through your phone, and see if you can at least view what's posted.
Yeah.
That way. Again, for this coming week, there's like with the course syllabus, the tracking calendar, all that stuff. There's nothing that you need to necessarily download right now. You're gonna want it at some point so you can keep track of everything. But for now, I can just tell you
I don't know what to do.
Yeah, for now I can just tell you you just need to do that one homework assignment and that one quiz. Are you able to get into my math lab through the computer?
Yeah, that I have no problem. The math lab that's on the tab, underneath like all the module class coursework and stuff like that.
Yeah.
Yeah, I can get into that.
Okay. So So just for our class, just go into my math lab and do module 1 homework and do module 1 quiz.
Okay.
Okay. What else was I just lost my train of thought.
It's okay, mom brain. I do it all the time.
Shoot, what was I gonna say?
After the class work, log into that.
Yeah, you just have to do module 1 homework, module 1 quiz, and what the heck was I gonna say? I don't know now. Can you can if you want to
So
look
it's
back
working
over
on
the
my
stuff.
phone. I just logged in from my phone. It is working on my phone. It did pop up.
Okay, good. So at least you'll be able to view it that way, and then you can also watch like the YouTube videos and everything like that. If you
Yeah, I watched your YouTube video from last week, so I did do that.
okay.
Yeah, it's downloaded on my phone. I'm just trying to figure out, is there a way that I can email it to myself and still download it on the computer now? Because maybe it might be only from the internet. I don't know. I'm trying to figure it. I'm just trying to work best through it as I can.
Yeah. I would honestly, this is probably not great advice, but I wouldn't even worry too much about it until Monday.
Okay.
Because nothing in those links, the documents that you're trying to download, is needed to complete anything.
Right.
If that helps, at least until Monday, until maybe you can hear from them again.
Yeah, that'll work. I'll do the math lab stuff. I could do that, so I will be okay.
Okay. All right. Good luck with it.
Thank you. I'll keep you updated if anything further, I can do any more, if I have any more problems.
Okay. Sounds good.
All right. Thank you.
No problem. Bye, Jay.
Have a good weekend.
You too.
Bye.
All right. We still got a bunch of people on the call. If you're still on the call, we're all done with class. You guys can head off and have a good weekend. I'm gonna be heading off as well. So if you need anything, just let me know. You can email me. Okay, I just booted everybody off. Can you hear me? What was that?
Yeah, I'm sorry. Yeah, I can hear you.
Okay. All right. I just booted them off.